We collected our data using interactive sliders. We could adjust the background music track, tempo, and instrument volumes in real time. We can then save these music parameters, along with the current game parameters, with a click of a button to form our dataset in CSV form. We then trained our neural network on this dataset. We then optimized our model using 10-fold cross-validation. To find our ideal hidden layer size, we tested on the validation data, and we found that 128 neurons gave the best performance. This size allows the model to capture important patterns without making it too complex. We compared different optimizers and we found that Adam yielded the best results. Adam adjusts the learning rate for each parameter during training. This adaptive quality is especially useful in our project because we generated the music by feel using sliders, which produces data with inherent noise and variability. Our experiment showed that the best configuration used 2 hidden layers. Our dataset only had 3 input features, so adding more than 2 layers made the network too complex. We found that the ideal learning rate was 0.02, as this provided the lowest MSE loss. We used various regularization effects to prevent overfitting. For example, we used early stopping with a patience value of 50. This means that during training, if the validation loss does not improve for 50 epochs, we stop training. Finally, we integrated our training model by exporting it to ONNX, and then used Barracuda, Unity's neural network inference engine, to load and run our model. By getting game parameters from our game manager, the system dynamically changes the background music in response to the game state.
For spaceship, I modeled environmental elements, including architecture, props, and terrain using Maya, ensuring consistent visual style and coherence with our project. I built complex materials using Maya's hypersheet, including metallic, emissive, and glass. And for animation, I designed a scientific-style portal effect using Unity shader graph and particle system. I applied techniques such as noise-based animation to simulate energy flow and spatial distortion.
The first alien is bigger in width compared to the rest, and therefore had its own complications. When giving it a skeletal structure, we had to be very precise and reach each side to ensure the body does not deform in an odd way. The second alien is more humanoid and easier to predict how the movement should look. As you can see in the video, the movement is an IK handle, which means that the elbow joint is connected to the shoulder and the wrist in a way that will mimic the motion of natural limbs. The third alien has 4 tentacles and required more attention to the rigging compared to the others, and extra research on how the movement should look. The speed of the motion can be controlled in Unity. If you're new to VR, don't worry, we've got an interactive tutorial that will teach you step by step how to play our game. Do you suffer from motion sickness? We've taken special steps to ensure that every player will have a positive experience when playing our game. We have 3 different comfort mode settings: vignette, pass-through, and teleportation movement.
Upon instantiation, each alien is given a text-to-speech speaker and randomly assigned a unique voice from 15 different presets. Every frame, a ray is cast from the player's viewpoint to detect whether the player is attempting to talk to the alien. The user is able to see what the alien hears and can look away and look back at them to reset their speech. Upon detection, the speech is converted to text and sent to a back-end natural language processor. This NLP has been trained on a variety of phrases that players might ask, as well as a series of automatically generated phrases based on the manually fed ones. It learns to sort these phrases into various intentions. Depending on the intention, the alien responds differently, with a variety of responses available to help conversation feel more natural. This feature nudges the player towards the right action when they're stuck, and is needed for determining the blood type, making interactions feel more typical to that of a doctor and patient.